Well, hello everyone. In this short walkthrough, I'm going to show how we move from exploratory charts to explanatory charts using Plotly Express, and how a tiny custom function from Module 8 keeps my visuals clean and consistent. This also ties directly to Module 7, data visualization, and then we'll bring in some of Module 8, the custom functions and organization. And why this matters, how we'll be spending our time today. First, we're going to explore the exploratory side of data visualization, moving into explanatory. We have a title and promise. We're going to talk about our imports, how this matters to the assignment, how I'm going to get there, how I generated the data set that we're going to talk through, what our exploration looked like, what the reusable theme function from Module 8 was for our data purposes, how our scatter and bar charts looked, and then what this means for the real world. So first, our title and promise. Here's why it matters. In analytics, having the data is only half the story. The other half is telling the compelling story that causes people to act. Exploration for me as the analyst is fast, it's messy, it's curious. And then the explanation for the stakeholder is just the opposite. It's tight, it's purposeful, it's obvious, it's very clear. And here is our quick plan for the demo today. So first, I'll generate a realistic data set about graduate student study habits. So we're looking at how those of us that are in graduate school are using our time to succeed in graduate school. We'll explore quickly in the data set that we've generated to look for patterns. We'll convert 2 of those visuals into polished explanatory charts. And along the way, I'll use a small theme function so every chart looks intentional. So first, for the imports, we're going to import numpy, pandas, and Plotly Express, so PD, NP, and PX, and also this random seed 42, because that will actually get us our data set that we need. So I'm generating my data set in Python so we can reproduce it. The data set is going to include, for the graduate students, the hours studied, sleep hours, number of cups of coffee, what kind of program they're in, whether it's a STEM, social science, a humanities program, and their final exam score. So the relationships are realistic on purpose. We know that more study time does help, but it goes to diminishing returns eventually. Reasonable sleep helps, and too much caffeine can slightly hurt performance. So why am I doing this? Because it lets me control the noise in the data and also demonstrate both the exploration phase and the storytelling phase without hunting for a perfect real data set. So let's start with the exploration mode, quick and imperfect. So for our scatter, we're going to look at study hours versus exam score with a base trend line. We see an upward slant as study hours increase, scores generally improve, but with diminishing returns around about 20 to 30 hours. For our histogram, we're looking at the distribution of sleep hours. With most students clustered around 6 to 8 hours, there's a tight tail on the short sleep side. No surprise for college students. So the quick correlation peaks of study hours and sleep correlate positively with score. Coffee has a small negative relationship, which fits the too much caffeine, lower quality rest story. The key point here in exploration, the speed matters more than the polish. I'm just trying to learn what's in the data and where the story might be as we're looking through. So now let's bring in our tiny helper from Module 8, a reusable function called apply theme. It does 3 simple things. 1, it standardizes fonts, margins, and templates. 2, removes distracting grid lines and zero lines where they don't help. 3, returns the figure objects so we can customize titles, notes, and annotations. And so why does this matter? It prevents me from having to repeat the same styling code in every cell, and it generates consistency across my notebook, my dashboard, or my slide deck, which to me is very important, especially as a business owner. I want things to be branded. I want things to be as consistent as possible. All right, so now let's look at the fun. Let's look at the data. So we're keeping study hours on the x-axis and exam score on the y-axis. Here we've added a regression line and we applied the theme so the fonts and the spacings are clean. We've renamed it in plain English to study hours and final exam scores. And we added just a little bit of an annotation that around 30 hours diminishing returns happen beyond that. So what changed between this one the chart now tells a clear story in one glance. Studying more helps, and there's a soft plateau. This is what the stakeholder needs. No one has to guess at the interpretation. The annotation and the labels do the work. So now for the bar chart. They're grouped by program and compute the mean score. Soft bars are the highest to lowest, or we sorted the bars by highest to lowest, so the ranking is immediately visible. And we applied the theme for visual consistency. The key is contrast and order. Sorted bars reduce cognitive load, so no extra work to identify the leader, which in this case is the PhD program. There's also no redundant legend, and the labels are sorted so the eye can go straight to the message. So for our bar charts, we grouped by program and computed the mean score. And how does this apply? So for academic analytics, advising teams can spot students who study a lot but sleep too little. Corporate L&D, they can evaluate whether time on platform relates to assessment performance and identify diminishing returns. For product analytics, same pattern, explore quickly, then explain one clear message per chart, and then add the module 8 themed, which scales on the visuals. The theme helper is a tiny example of a custom function. Write it once, use it everywhere. And you can do the same with data cleaning, outlier handling, or metric evaluation. Functions reduce repetition, bugs, and friction for teammates. So just to recap quickly, and against the rubric, we distinguished exploratory, me, versus explanatory for stakeholders. We built a scatter bar and histogram, then polished 2 examples for storytelling. We used a custom function to codify style decisions. The same idea applies to every repeatable step. Wrap it in a function, document it, and return objects like the figure for flexibility. This approach improves clarity for viewers and keeps the code base maintainable for the team. Thanks for watching. So excited to continue to dive into Python throughout the rest of the semester with you.